Okay, we're going to go ahead and get started on page 661. So get your book open to page 661. We are now getting into geometry, which is all about shapes and how they work and how we find area, how we find perimeter, and all that good stuff that goes along with it. But on 661, there's some good vocabulary that we need to take a look at. So the first one is a polygon, and then the second one is a parallelogram, and then the third one that we're going to talk about today is a rhombus. So what we're going to do is we're going to walk through each of these three vocabulary words, and we're going to fill in this circle before we actually get onto the lesson. So a polygon is a closed figure formed by three or more straight lines. So what I want you to do is I want you to go ahead and just write the word polygon on this outer circle right here. And then we're going to draw a picture of what that actually looks like. So it says that it is a closed figure that has three or more straight lines. So it could look something like this. It could look something like this. There's nothing really that it just is going to have four sides, three or more sides, and it's going to be closed, meaning that you could fill it in and nothing's going to come out. The next one is a parallelogram, and I want you to go ahead and write that right here. Okay, and a parallelogram is a quadrilateral, which means four sides with opposite sides parallel and opposite sides the same length. So, for example, this is what a parallelogram could look like. And I'm going to try my best to make sure that they are all even. So you see that this side right here is parallel and the same length as this side. And then you're going to see that this side right here is the same length and parallel to that side. And the last one is a rhombus. So a rhombus is a parallelogram with four equal sides. So it's actually going to maybe look something that's hopefully kind of like this, where all the sides are the same length. Okay? So you'll notice that the rhombus had longer sides, but not the rhombus, but the parallelogram had some longer sides, and the rhombus has sides that are all the same length. Okay, let's go ahead and turn to the next page. So what we're focusing on today is we're focusing on area of a parallelogram, and we're working on what is called the formula, and this is our formula for the area of a parallelogram. The A stands for area. The B in this situation stands for the base, and the H stands for the height. Okay, so again, whatever I'm writing up here, you should be writing in your paper as well. So let's talk about the base and the height. So here's an example of a parallelogram. Okay, remember a parallelogram is a quadrilateral with with the opposite sides being parallel and the opposite sides being the same length. So you're going to see right here, this is where the base is, and it says the base of a parallelogram can be any one of its sides. The height, notice, is right here. What you're going to want to see when you are looking for the height is you are going to want to look for this 90-degree angle, okay, a right angle. And a right angle is marked with a square right there. That means that it is a right angle, which means it is 90 degrees. Okay, so when you're looking for the height, you really want to make sure that you are looking at that. So basically, our formula is A equals base times height. So all we're going to be doing is multiplying our base times our height to get our area. All right, let's take a look at this example down here for number 1. Okay, it says find the area of the parallelogram. Again, you always need to write the formula. Whatever you're doing, the first thing you have to do is write the formula. That way you know. So A equals base times height. So here's my base, and we're going to see how many that is as far as units. 1, 2, 3, 4, 5, 6. So that is 6 units for my base. Now let's take a look at the height. There's 1, 2, 3, 4, 5, 6, 7, 8, all the way up into the corner. Notice I went straight to the edge and I looked for that 90-degree angle. So we said that there was 8. So all I'm going to do is I'm going to take 6 times 8, which is 48. And since we don't know whether this is feet or inches or squared or meters, we're just going to call this units squared. Now, one really cool thing is right over here, okay? So circle this, star this. When we're talking area, it says an area measurement can be written using abbreviations and the exponent of 2. So if we're talking square units, units squared, square inches is inches squared, square feet is feet squared, and then meters is m squared. Okay, so those are some good key examples that you can use to look at while you go through this lesson. All right, let's take a look at this example right here. Okay, so notice you're going to see on this one that they actually put the 90 degrees on the outside. Does that change our height? No, our height is still going to be wherever it is perpendicular, okay, wherever it is perpendicular from the base, okay? So here's my base, and this is perpendicular, okay? So my base is 20, and my height is 11, so I'm going to take 20 times 11, and I'm going to get 200, well, it's actually, they want us to estimate this one. So actually they're having us estimate. So 20 times 10, which is about 200. And so 220, because you'll notice that this comes out just a little bit longer. And so we were just rough estimating that it was about 220 centimeters squared. Okay, so let's take a look at this example right here. And we're going to go ahead and do these together. It says, do these problems to find out. So basically we're going to find the area. So the first thing you're going to do is you're going to write A equals base times height. So this is for this is for question A. So A, we don't know the area yet, but we're going to replace our B with our base, which is our bottom. So 1, 2, 3, 4, 5, 6, which we know is 6 times our height, and we see that we're looking for the perpendicular line from our base. 1, 2, 3, and I do 3. So my A is going to be 6 times 3, which is 18. Do we know what unit of measure? Nope. So we're going to say units squared. You have to have that square in order for it to be correct. Otherwise, it'll be wrong. Okay? All right, let's take a look at B. Since we're finding the area of a parallelogram, we have to write the formula. A equals base times height. Okay, so here is my base, and notice that my base is 4. So A equals 4 times, and then look at my height. It's got to be the one that's perpendicular, which is 16. Why is 17 not perpendicular? Because if I were to keep going, look at what's happening. Okay, they have to be perpendicular, creating that 90-degree angle. You need that 90-degree angle. So I'm going to take 4 times 16. A equals 64. Let's look at the label, which is meters squared. Okay, pretty easy, right? All right, let's take a look at the next one. Formula. A formula is an equation that shows a relationship among certain quantities. To find the missing dimensions, use the formula for area of a parallelogram. Replace the variables with the unknown measurements, then solve the equation for the remaining variable. So basically now we get to pull our algebra back in, and we're going to replace certain things that we know, and we're just going to solve the problem like we normally would. We're going to be doing inverse operations. It is just bringing it, everything is coming back full circle. Okay, so let's take a look at this example for number 3. It says, find the missing dimension of the parallelogram. Area, A equals base times height. Okay, if we're looking at this right here, we notice that we have the area, we have our base, but what are we missing? We're missing our height. We don't have a dimension of that. So what we did here is we replaced my A with 45, we replaced my B with 9, and we left H the same. So since we're multiplying by 9, the inverse operation of multiplying by 9, because we want to get that H by itself, is to divide by 9. 9 divided by 9 is going to leave me with H. 45 divided by 9 is going to leave me with 5. So the height is 5 inches. Let's do some example problems so we can figure this out together. Okay, so take a look. Remember, A equals base times height. We know what my area is, which is 48. We know what my base is. Nope, we don't know what my base is, so we're going to leave that alone, times 6. Now, again, going back to algebra, knowing what we know about algebra, we want to try to get that variable by itself, which means we are now going to divide each side by 6. That's going to leave me with my base. And 48 divided by 6 is going to leave me with 8. So my answer is 8 meters. It's not 8 meters squared because it's not the area. But that, I'm sorry, of my, yes, of my, it's going to be of my, equals my base. Okay, it's not my area, it's my base. So my base right here, we just said was going to be 8 meters. Okay, and we can check that by going 8 times 6 is 48, which is my area. Okay, let's take a look at D. So take a look here. This label is on the 90-degree angle, which is the what? The height. So we have the height, but we don't have the base, but we have the area. So A equals base times height. My area is 96, but I don't know my base. Remember, this would be my base right now because that is perpendicular with my height. Okay, so my base we don't know, oops, but my height is 8. Since I'm multiplying by 8, the inverse operation is to divide by 8. Okay, and when I divide by 8, this cancels out. I'm left with my base, and I'm left with 12, which means that I have 12 yards equals my base. So my base right here would be 12. Okay. Oops. I'm not sure what just happened right there. Went a little bit crazy. Okay. I'm going to stop this video. You do need to watch the next video as we do a couple more practices, but this is the learning part, and now we're going to do the practice. Everybody must do the practice. There is no skipping this next part, so you're going to watch part 1, and then you're going to watch part 2.